Okay, let's talk through what's the plan with merging k-sorted lists. This is one of the simpler, hard Leetcode problems. Okay, so the basic idea is that if we have these three linked lists, they're already sorted with least first 1, 4, 5, 1, 3, 4, 2, 6. The goal is to always take the smallest head element out of these lists. So if you were to merge these, we'd always pick the 1, and then the next smallest head element would be this one. These would be connected in a new list. All right, so then we have 4, 3, 2. Next smallest is the 2. Then we have 4, 3, 6. 3 is the smallest. All right, then we have 4, 4, 6. We would take these, the 4, we have 4, 6, take the 4, we have 5, 6, just take the 5, and then we take the 6. And then we have it merged. All right, so let's just back this up and talk about what's the fastest way to do this, the most efficient way. You can always go and find the minimum across all of your lists. That's an ON operation if there's n lists. Well, let's say k. This is an OK operation with k lists. You can make that go even faster. Let's say you have thousands of lists that you have to merge together and sort. You could make this an O log n operation down to almost an O1. So what we can do is we could put the head of all these lists into a heap, and just always pick the minimum value off of that heap, and then build up our list that way. And every time we pop one off of the list, we can put the value back in the list. So let's say we have our heap representation. It would look like 1, 1, 2 inside the heap, and then always give us the smallest one to pick off. Okay, now let's write some code to do it. All right, let's write some code. Okay, so we already plan on using a heap. Python has a built-in heap, and we just need to have a few functions from it. It's called heapq. We just need heapify, which will turn any list into a heap. Then we need heap pop and heap push. And we should be good to go with that. All right, so let's say we want to always have a result, which will be a list node. Since this is a list problem, I want to build it kind of iteratively. I'm going to use a dummy front node on the list, and then a pointer to where we are on the list from there. So we have our current position pointer. We have our simple paste case. So if list is null, or there are no lists, is it returning this empty list node? This list node has a default value and stuff like that for that empty case, and this also is supposed to return an optional. So I think that's where we return none, right? There's nothing to merge. All right, so we have our k heap for our lists, and then all we have to do is heapify that. Okay, now we need to build up this list. So let's say we want to so we're gonna use the index of the list to keep track of which lists we're pulling from. We can't just put these lists themselves onto the heap because they're these weird list node wrapper objects rather than just native Python lists. A native Python list you could, because there's a less than defined. This class is on the less than defined, and it's difficult to define a custom comparator for this. So we're just going to use which list we're talking about here. Okay. So we have our IDX in the lists of lists, and then the list itself. Okay. And And then we say if L is not none, because this is optional. There can be nones on this list. So we go check for none. We're just going to push it. So heap push onto our K heap. And what we're going to push is the value in that list and the IDX. So the value is just helping us sort those indices into lists of lists. And that's what we're really going to use to access it. And I'll say this while our K heap isn't empty. What we're going to do is we're just going to pop. So this will be IDX, pop from our K heap. And we're going to say for our current pointer into the list, the next spot is just the next element based off that IDX. And now we need to advance our current. So that one. And then we need to advance that list itself. And let's say if there's still elements on that list to consume, so that means it's not none. Wow. So if it's not none, we have to push it again. All right. So as we loop through this, we're just popping off our heap, taking out that element, putting in the merged list, moving on with our lives. And we're reusing these list nodes. We're not building new ones or anything. So this should be very efficient. It just needs memory for the heap. Everything else is just reusing what's already in memory and modifying what's sent to us. And since our list has this dummy front node on it, we just have to return result.next, and that should do it. Oops. I typoed. That happens. I was typing fast, not paying attention. All right, there we go. So we did all the basic cases. I'll submit it. Bam! That is on the extremely fast side. I don't think you can do any faster than this. If you can get a faster solution than this with better performance guarantees, show me. Add a comment. Send me a video of it. Whatever. It'd be fantastic. All right. If you have other Leetcode questions or career advice questions, comment below and I'll answer them. I'll make a video, give you a call out. Thank you.